I'm going to touch on some of the nuts and bolts of the infrastructure renovation. Just to highlight some of the goals: to upgrade life safety and code compliance, one of the major goals. Michael spoke upon earlier, the sprinkler system at a date, fire alarm systems at a date, to replace the dated infrastructure and its lifespan well past, and to improve the efficiency of the campus. We are moving towards a fully sprinkled campus above code. Michael mentioned that we're coordinating with New York City DOB. We meet with them every 2 weeks to review the plans, one-on-one, walk them through the project very carefully, and we respond to their input. We had the opportunity with the fire alarm system to incorporate some diversity and some hardening of the life safety systems. Now, hardening infrastructure is very expensive. On a site, diversity is a lot cheaper. And with this larger campus, we were able to incorporate location diversity in some of the key aspects of the life safety systems. So remote locations for fire command centers, for generators versus Con Ed services, multiple fire protection services to the campus were incorporated into the design. We were also able to create an integrated command center for the security, fire alarm, and PMS functions for the campus. The campus also includes some above code items like fire tanks as well as a fire pump, scare pressurization as well as smoke-free fire scares. The campus itself, the existing campus is served by 4 208 volt vaults. They're located throughout the campus. That distribution over 50 years old. The wiring, the Con Ed feeders have been failing often. We're replacing them with 2 6 times 2500 kVA transformer vaults in 2 disparate locations around the campus, north and south. We're replacing the existing Con Ed steam chillers with a hybrid plant that will allow us to use the most efficient source at the time, using real-time data for energy costs. Throughout the 50 years, different program units within the UN would build their own tiny data center to serve their program, or sometimes hire little data centers below their desk. We're bringing all these mini data centers to a tier 3 data center with higher level of reliability and redundancy. Michael had shown earlier a picture of one of the high-density modules. And anyone familiar with high-density data center design, these racks are designed to handle up to 20 kW rack. That drives the space efficiency very high, and also drives the overall equipment efficiency to a high level. Some of the other goals for efficiency: water efficiency, energy efficiency, and air quality. The availability of potable water is a worldwide problem and became one of the major goals for the project. We are looking to achieve close to 40% savings over EPAC. Some of the engineering tools we utilized for the project include CFD, energy modeling, daylight modeling, and shading studies. This is one of the smallest CFD models I've ever used on a PowerPoint, but there you can see the data center. Reducing the loads. What are our MEP systems responding to? One of the first steps is to reduce the amount of cooling and heating required, and what are we reacting? We're reacting to the envelope. So we work closely with Bob Heinches and his team and the project team on both the program and the building systems, and also the level of insulation in the wall. Active shades and blinds. We visited other buildings that had incorporated this kind of technology, including the New York Times building, Bank of America, to see what had worked and what hadn't worked for them, and incorporated the best of those technologies in our campus. We consolidated and combined similar programs. As I said before, the UN is a very flat organization. Each program unit would have their own miniature component of the server, their own storage section. Part of the program is to bring together some of these disparate programs to create both space efficiency in the campus and energy efficiency. Down to the component level, we used ECM motors for any of the larger motors above 5 horsepower on campus. We take a close look and our specs are written to squeeze efficiency out at the component level for our air handling units and the chiller plant, transformers, and other equipment. The building management system itself is incorporating many of the latest control technologies. CO2, we're using CO2 to measure all the occupied spaces throughout the campus. We're adjusting it to increase outside air. When we find that the level of CO2 within the campus is worse than what is available, or typically available outside, and then when we find that the building is not loaded, we're throttling that all the way down. If a typical outside air component of an air handling unit might be 20%, we'll bring that all the way down to 5% if we're capable of measuring that with the CO2 sensors. As I mentioned before, our steam electric hybrid chiller plant, we have 3 electric chillers, 1,800 tons, 2 steam chillers at 2,500 tons. Conduits bringing in steam at 150 pounds, and we're using that steam not only for cooling for peak, we're also using it for heating and domestic water. One of the best tools we used on the design to bring the team together was the energy model. It gave us a common goal where we could see our work reflected in real time, our efforts on how each one of the design team members could affect the overall goal for the design. Here we worked with the client and the other team members to pick the most efficient chiller plant. We modeled several options from an all-steam plant, an all-electric plant, and eventually ended up on the left-hand side with a hybrid plant. We worked with Bob closely to evaluate different facade options, double glazing, low iron, triple glazing options. We also used it to model different options for the building that John Beering highlighted a minute ago, the Secretariat building. Here we're measuring fan coil units versus VAB. Again, one of the driving elements of this was how high could we get that ceiling? Rainwater harvesting. This is a snapshot of the service drive. This is about 1.5, maybe 2 city blocks of our service drive. It runs adjacent to the FDR. We're collecting rainwater in these tanks, both war stained water and then cleaning it and using it for flushing toilets in the conference building. Saving about 70,000 gallons in these tanks. This is just a simple schematic of what's happening. Collecting the rainwater, aboard, collection tank, clean it, and pump it up through the building. We're collecting about 3 million gallons a year, the equivalent of 122 homes. We're also at the component level for the bathrooms, using the most efficient fixtures available now. Compared to heat pack, that's with their efficiency, we're saving 30%, and total combined with stormwater, it's about 307 homes a year, the domestic water typically consumed by home. That, in a nutshell, a little bit of the infrastructure. Thank you.